Wonderful. Well, up next, I hear Ben Thomas has some things he would like to teach us with Linda Gedemer at the virtual production stage. Ben, what do you have for us right now?
Well, absolutely. I'd be remiss, though, if I didn't take the chance to shout out some of the VGK technology staff. I'm a Dallas Stars fan, and I've got to admit it, but my favorite in-arena experience is here in Vegas, and I've got to shout them out and thank them for all the great work. But I'll tell you what, we've got some great conversations happening in the classroom right now with our friend Linda Gedemer. Linda, thanks so much for joining us on the show today.
Thanks for having me today.
You know, Linda, I want to ask for folks who may not be familiar with you or may not know you, what would you say your day-to-day looks like, and where's some of your expertise?
Oh, well, my day-to-day is lots of projects. I'm happy to be managing a fantastic team of people at Faith Group. So I'm both an AV engineer, but I'm also an acoustical engineer. So my work varies between those two. My project works go anywhere from museums up to airports. So really exciting, just cross-vertical of projects to work on.
Well, that's fantastic. Linda, the crux of our conversation today really is about the intersection of acoustics and kind of the architecture side of things, the build and design side of things. And I want to ask, what are some common challenges that maybe from an audio design standpoint, folks may not consider whenever they're either trying to install a system into a room or maybe trying to just build a system in general?
Well, one of the biggest issues that we come across in interior rooms is flutter echo or standing waves. And the problem with this is a lot of times we're going in, even if it's a new design or if it's an existing design, and this happens a lot in especially conference rooms, where you have these rectangular rooms with these perfectly parallel smooth walls. And what happens is you end up with a wave, an acoustic wave that travels out from the source, hits the wall, and then will come back, and the two waves, the outgoing wave and the reflected wave, will sometimes add constructively but also destructively. And what I mean by that is the wave will come back and a certain portion of the wave will add onto itself, and all of a sudden you'll get this rise in amplitude, but other parts of the waves will add together destructively, and then they'll cancel each other out. And so you can actually physically walk through a room and hear this phenomena where you'll hear it get louder, and then the sound will go away, and it'll get louder and go away. And this happens at a fundamental frequency and then multiples of that fundamental. So that's a real issue. So one of the things that you want to take a look at is, in new construction, is there any way that you can keep from building those parallel walls? Even adjusting one wall slightly by a certain angle can keep those annoying standing waves from happening. So another way is to treat the wall so that the wave doesn't get reflected and come back.
Well, Linda, I want to ask, obviously you talk about sound coming from speakers and things like that, but the same science applies to microphone technology, right? Does the same sort of design process apply for the acquisition of audio as well?
Yes, definitely. So, anytime that you have smooth parallel walls, this phenomena is going to happen, and it's going to affect how people hear the sound, how microphones pick up the sound, where you should be putting speakers. It really is the convergence between good architectural design, good acoustical design, and also good audio system design.
Well, unfortunately, whenever we're designing a lot of these rooms, we don't have the benefit of a structural rebuild in most cases.
Yes,
so it's
unfortunately.
A lot of times it ends up being a retrofit. And one of the challenges naturally is because you've got that existing space and you've got all the different wavelengths and things like that, it just becomes more challenging. What would you say some best practices are for folks who are looking to design systems but have to do it maybe in a retrofit facility?
Well, in a retrofit, what we try to do is I like to always say, try to solve acoustic problems acoustically, not electronically. And standing waves is definitely an acoustic phenomenon. So ideally, if you can, treat the wall so that reflection doesn't come back. You want to treat it so that either the sound gets absorbed, which at mid and high frequencies is easier to do. Low frequencies are very, very hard to absorb. It takes very specifically tuned bass traps, very difficult. So usually I tell people that if you have that reflective wall, treat that wall with absorption for mid and high frequencies, or treat it with diffusion panels in order to scatter the low frequency energy so it doesn't come back as this perfect reflection, which is what wreaks havoc. So
Linda, last question, and this is a quick question. You know, you mentioned that our community is really good at the technology and the engineering and development side of things. We might lack a little bit sometimes from an architectural and design standpoint and acoustical design as well. Where do you recommend people start, maybe from you know, who have that electrical expertise, but maybe want to start learning a little bit more about the audio side of things?
Well, the good place is you could take one of my acoustic workshops when I'm here at Infocom. There's a lot of information about this out, you know, even in the internet to find out about this. So it's really, you know, just knowing this problem exists, it's great to go into a project where you can easily identify this problem, you understand what's causing this problem, and then you also understand how to treat it. You can either treat acoustically, or you can carefully select the position of your speakers so that they don't aim straight at a wall. You can cant them down a little bit and just keep that reflection from happening.
Well, Linda, thank you for your expertise, and thank you for joining us in the classroom today. We hope you have a great rest of the show. I'll tell you what, one thing I could use going through the rest of the show is a nice hot cup of coffee is what I need, which actually was the catalyst for a lot of the conversations that we had in our next